Welcome back to this tutorial. Today we are going to be looking at another interesting library, the Seaborn library. And the Seaborn, it's actually somewhat easier to deal with than the Matplotlib library. Yes, it was built on the Matplotlib library, so it provides better ways of exploratory data analysis. So let's just explore two basic plots in the Seaborn library to get us started. So here we're going to be looking at pair plots and heat maps, and we would explain how to draw insights from them. So I'll be using the Seaborn library. I'm importing Seaborn as SNS. Again, this is just the custom. You can import it as whatever you want. You can import as PD, as SO, anything you like. But SNS is basically the traditional way of importing Seaborn, just as NumPy as NP, Pandas as PD, like that. So import Seaborn as SNS, and then I'm loading a data set from the Seaborn library just for us to practice. So here, let me see data. Yeah, so you see the penguins data, we have the species, we have the island, the bill length, the bill depth, the flipper length, the body mass, key, and the sex. So that's the penguin data set. So I want to see a pair plot of this numerical data set. So mind you, pair plots work only on the numerical data set. It works only with the numerical data set and not with the objects. So we simply just say SNOT dot pair plot, and then we pass in the data. And if I execute this, yes, so you would notice that we have just 4 features here, and we don't have the sex, the species, and the categorical variable. So as I said earlier, the Seaborn, the pair plots, it works only with numerical variables. So look at this plot. What do you think it does? It's a pair plot and it shows correlation between all of your variables. So when you look at this, let's examine this properly. You see that the label here, we have bill length, bill depth, and then we have flipper length, and then we have body max G. So we also have B length here, we have bill depth here, we have flipper length, and then body max G. So what it does is it plots all of the variables together. It plots 2 of them together, like it plots each of the variables together for you to see if there's a correlation between any of the variables. So here, this first plot here represents the bill length and then the bill length. So this one here represents the body mass index, body mass G, and the bill length. This one here, the flipper length and the bill length. This one here, the body mass G and the bill depth. This one here, the flipper length and the bill depth. I hope you get how it works now. So, but when you all these ones that are represented in histograms, they are the ones that they are the diagonals. When you are plotting the same things together, the same feature. So here, this one represents bill length and bill length. That's why you're having histogram here. This one also, it represents bill depth and bill depth. This one as well, flipper length, you see, flipper length and flipper length here. And the same thing, you see, body max G and body max G. So all these ones on the diagonals represent the same features plotting together. When you're plotting the same features together, so you have, so these ones, you can ignore these ones at the diagonals. So but you pay attention to each of these ones that are scattered. So let's examine each of these and draw inferences from them. So when you look at this, let's look at this body max G and bill length. So from this scatter plot, we can see that there is somewhat a linearity. We can observe a bit of linearity, collinearity between these two features. It seems to be it seems to be correlated. So it seems the higher the body mass G, the higher the build length. So if you have to plot a regression line here, you will see that we would have a straight line that would pass through some of the points here. So but then we still have a lot of outliers. So we just observe some just some linearity. So but when you look at these here, the flipper length and the body mass G, the line seems to be more straight than for here. So we can, and when you also look at this body mass G and flipper length, it's the same thing as flipper length and body mass G. So this graph and this graph is the same thing. You see that the linearity, it seems to be very linear. So we can say there is a correlation between the flipper length and the body mass G. So and the correlation will be a positive one. That is, the higher the body mass G, the higher the flipper length. So but when you look at this one here, flipper length and build depth. So well, the there seems to be a correlation as well, but the correlation seems to be negative, meaning the lower the flipper length, then the higher the build depth. I hope you understand how I'm making these inferences. So that is just how you observe all of this. So looking at all these plots when you are working with a data set makes you draw inferences that can help you draw insight and provide solutions to a particular problem that has been given to you to solve. So that's just that about pair plots. So to represent this further, we can look at the correlation, the exact correlation on an heat map. So on an heat map, we'll simply just say we'll use the same data we created here, this same penguin data. So I can define a variable named correlation, and I'll just say data dot core. So this data dot core is to calculate the correlation of the variables. So you say core now, you see I have the correlation. So but I would not be able to explain anything. I will not be able to understand anything from this table, but I will be able to do so if I represent it on a heat map. So if I say SNS dot heat map and then core, yeah, so this is a heat map. This is a heat map. So what does this mean? This seems like, it appears like just an image, and you would be wondering what the hell does this mean. So this is a heat map. So when you look at this color bar right here, where you have it's just a guide for you to know if values are correlated or not. So this one here represents a positive correlation. So any value that is, the higher the value, the closer the value to 1, then the stronger the positive correlation. And you can see minus 0.4 here. It is a negative correlation, meaning that any value that is close to minus 0.4 or even higher, so the deeper the color here, the higher the negative correlation, while the deeper the color here as well, it implies a strong positive correlation. So when you look at all these, the ones at diagonals, they are the same feature, so it will all be correlated because this is just build length and build length. This is build depth and build depth. It's the same. It's basically the same features, checking the correlations against each other. So you ignore that. So when you look at this, you see that this is very, very deep. You see, we have the deeper color here, so we are seeing the same thing here. So when you look at where you're seeing this, is flipper length and build depth, and the same thing here too. build depth, and flipper length. And as we have rightly, and this is a negative correlation, and as we have rightly established here, we've seen it that they are correlated but negatively. So this will just tell you that the the higher the flipper length, the lower the build depth, and vice versa. So that's just how to make inferences from a heat map, because when you're working with data sets and you want to, as we dive, we are going to go deeper, and we are eventually going to go into machine learning. So when you're building a machine learning model, you would want to do away with values that are correlated strongly, because it will create noise in your model. You understand this much better when you start working with machine learning, but that's just basically what an heat map, what this is just basically what a heat map is, and how we can draw inferences from a heat map. So that is all about the that is all what we'll be covering on the Seaborn and the Matplotlib library. I will share the official documentation on the Slack channel so you can explore more and then you practice more. So I hope you're enjoying these lectures and tutorials. Feel free to drop your questions on the Slack channels. I'm always available to attend to them. Thanks for watching.